Hi and welcome to the On Maths prediction for the Edexcel Foundation GCSE Maths Paper 1 for November 2018. Enjoy! Hi and welcome to this On Maths prediction. Now this prediction is on our website at onmaths.com. And the beauty of doing it on the website is that the numbers change each time, so you can have absolute practice without just remembering answers. So there will be a link that comes up above my head now, right there probably, who knows, that will take you to the website. So the predictions that we do are based on previous exam series. Now I think we've had 3 series so far, so we've got quite a lot of information about what the exam board likes to put on which paper. So what we've done is we've looked at what questions come up a lot, and we've put those on, and also what questions haven't seemed to come up at all, and sometimes that's a good indication that it's probably their time to come up. So there's a kind of a nuance and kind of a bit of guesswork in it, which is why we always say do not just solely rely on this prediction, but make sure that you do all your revision and use this as part of your revision. Now we've changed things up a little bit this year, and we're only going to be focused on skills on this prediction. So some of you might do this prediction and it might feel a lot easier than the exam. The reason for that is that AO1, which is the skills-based questions, make up about half of the paper, and maybe just slightly under half of the paper. And what they are, the kind of questions you walk into, and you walk into the exam and you've kind of seen them before, and so they're a bit easier for students to do. Now the problem solving, the real life application questions are what the exam boards are saying are more difficult. Students get less marks on those. Now they're less easy to predict because problem solving questions are essentially questions you should never have seen before and have to work out a solution for yourself. Now there's loads of stuff on our website to help you with that, and there's loads of other stuff out there. On our website is Demon Questions, the mini mocks and the topic busters will really help you with that side of things. But this prediction is all about understanding the skills. All the problem solving and real life application ones, the harder questions, rely on you understanding the skills as well. So it's really important that you use this paper to just go through and check that you understand the most likely skills to come up on the paper. So the grade boundaries on this paper are only for the skills, so you need to make sure that you understand the other stuff as well. If there's any questions on that, please write them in the question part of this video below me. And if you like this video, please click like, it really helps our channel out. And if you want to see more from us, please click subscribe. Thank you. To fill in this frequency column, all we've got to find is how many 11s, 12s, 13s and 14s there are. So I'm going to start with 11, and I can count 1, 2, 3 11s. Then 12s, 1, 2, 3, 4, 5 12s. 13s, 1 13, and 14, 1, 2, 3. And it's a good idea in the exam to cross them out when you've counted them, and therefore you don't accidentally count them twice, and you can have a look and see if you've got any left over. What you could also do is add a tally chart to the table if it helps, but if you do a tally chart, make sure you write down the number as well. So to cancel a fraction down into its simplest form, we've got to find something that we can divide top and bottom by, and you have to make sure that you can divide top and bottom. Now they're both even numbers, so what I can do is halve top and bottom, so that becomes 12 over 30. They're both even again, so I can halve top and bottom again, so that becomes 6 over 15. Now you might think we need to stop there, but actually 6 and 15 are both in the 3 times table. So I can divide them both by 3, which will make 2 over 5. So my answer is 2 over 5. Now I could have done that in a quicker step. I could have started by dividing by 4, or I could have divided top and bottom by 12, and it would have done all of this straight away. I could just divided the top by 12 and divided the bottom by 12. No matter which method you pick, you'll always end up in the same place as long as you simplify it enough. Okay, when we're finding perimeter, it means distance around the shape. So if I put a little dot here, we need the distance here, which is 9.3. Then we need to add on the distance here, which is 15.3. Now the difficulty is we don't have this distance here. Well, we kind of do. It's on the other side though. So that's 9.3 there. So we need to add on a 9.3. And then we need this distance here, which is the 15.3 from the top. So what I need to do is add together 9.3, 15.3, another 9.3, and another 15.3. Okay, so let's add going downwards. So that's going to be 12. So we're going to carry the 1. That's 9 plus 9 is 18. 5 plus 5 is 10. So that's going to be 28 plus the 1 at the bottom, so 29. And then that would be 4. So it would be decimal point here because it's in line with that. And obviously if this is on the calculator paper, you can just type into the calculator. Now something that some people do, which is absolutely fine, is they add these two together and then they just double it, because the 15.3 is repeated there and the 9.3 is repeated there. So they do 15.3 plus 9.3 and then just times that answer by 2 and you get the same answer. So this question's asking us to convert worded numbers into just numbers. So it says 2,605. So when we're thinking about numbers, we think about what column each of the digits are in. So we have our units column here, we have our tens column here, we have our hundreds here, and we have our thousands here. So we have 2,000, so I can put a 2 in here, 600. Now it doesn't say any tens. If it said 35, I could put a 3 in the tens column, but there's no tens in that number, so I'm just going to put a 0 and 5. Now when you look at that number, you think, oh, that's 2,605, and that's what it says in the question. So that's our answer. Okay, so we're asked to solve, which means find out what x is. So I'm going to put my lines in. Now on the left hand side here, we've got 12x. Now that is a times 12. Okay, anytime you have a number next to a letter, it's timesing it. So to get rid of that, which we need to, because we want x equals, we need to do the opposite of times 12. So the inverse operation of times 12. The opposite of times 12 is divided by 12. And we have to do it to both sides to keep the equation balanced. So we're left with x on the left hand side, and we're doing 36 divided by 12, which is 3. So x equals 3, and we can check that by putting it into the original equation. 12 times 3 is 36, so that is correct. Alright, so we're asked to find 6% of 120. So I'm going to start off by finding 10%. And to do that, I'm just going to divide the 120 by 10, which will give me 12. I'm then going to work out 5. And to do that, all I'm just going to do is halve the 10%. And that will be 6. And then I'm going to find 1%. Now to do that, I'm just going to get the 10% and I'm going to divide it by 10. So I'm going to get the 1% and just divide it by 10, which would be 1.2. Now to get to 6%, I'm just going to add the 5 and the 1%. I'm just going to add this one and this one to get to 6%. So I'm going to add 6 and 1.2. And I can do this using a quick column. So 6.0 plus 1.2. And so 0 plus 2 is 2. 6 plus 1 is 7, so my answer will be 7.2. So two things we need to know in this question. First thing is that angles in a triangle add up to 180, And the next thing is this thing here means it's 90 degrees. It's called a right angle. So to work out what x is, we're going to take away the two angles we know away from 180. So we're going to add together 90 and 48, take it away from 180. So 180 take away 90 plus 48 is 42 degrees. So x is 42. And you can check that by adding that to 90 and 48, and it equals 180. For your exam, you need to understand the different properties of the different types of quadrilateral and their names. On this one, we're told that we have one pair of parallel sides that are one set of parallel sides. So if I draw out a shape, a four-sided shape that has one set of parallel sides, you can tell that that is a trapezium. In fact, that's the only property of a trapezium, is that obviously it's got four sides and it just has one pair of parallel sides. When collecting like terms, it's really important to know what is a like term and what isn't. This is an x term here, and we've got another x term here. But this is an x squared term here, and this is another x squared term. Now you can't add or subtract x's and x squareds. You can multiply them, but you can't add them or subtract them. So we're going to do the x squared first. So we've got 8x squared, take away 5x squared. That will give us 3x squared. And then we're going to do the x terms. So 14x plus 8x, which is plus 22x. And that is our answer. You can't simplify that anymore because you can't add x terms and x squared terms. So to find a coordinate, it's really simple. There's only one mistake really that people make. The first thing to do is find out what the x coordinate is. So the x coordinate is 2. And so the first coordinate is 2. Then find out what the y coordinate is. So the y coordinate is minus 3. Now some people think of this as starting in the middle and going along the corridor to the 2 and then down the stairs, or up the stairs. This one it's down the stairs to minus 3. Now it's really common for students to get these muddled up, so just remember we always do the x, so the horizontal, we go across first and then the y, which means we go up or down. So just like fractions, with ratios, when you simplify them, you have to have integers or whole numbers. So we've got 0.4 to 6, and the first thing to do is either times it by 10 or 100 or 1000 to get rid of all the decimals. So I only need to times this by 10, so I'm going to times both sides by 10 to get 4 to 60. Don't forget to times both of them by 10. Now I can simplify that a little bit further. I can halve both of those to make 2 to 30, and I can actually halve them again to make 1 to 15. Now if you found a different method to get 1 to 15, that's absolutely fine. I could have divided the 4 and the 60 by 4 and that would have got me there a little bit sooner. I could have divided the first decimals by 4 and then times them by 10. There's loads of different methods of doing it. As long as the answer is 1 to 15, then you're absolutely fine. Okay, so we're asked to round to 3 significant figures. So what I'd try and do first is write the number down. Now, with significant figures, we start counting at the start of the number. We don't start counting at the decimal point. So I'm going to start counting here. And I'm going to count 1, 2, 3, and I'm going to draw a line down. Now, all the numbers to the right of that line are going to reset to 0. But before they do, we need to look at this number, and this is called our decider number. If that number that I've circled in blue is 5 or more, it means the 7 goes up to 8. If it's less than 5, the 7 stays the same. Now because it is 5, that 7 will go to an 8. Now be careful here, the numbers to the right don't disappear, and some students, when they've done decimal places, they think they just go away. With significant figures, you have to remember that they turn to 0. Now they do the same with decimal places, it's just because they're after the decimal point, we don't need them anymore. But these 3 zeros here are what we call placeholders. So, for instance, if you're asked to estimate the size of a crowd, and there was 207,518 people, you wouldn't say that that was roughly 208 people. You would say that's roughly 208,000 people. Alright, so in this question we're asked to write 8% as a fraction in its simplest form. Now percent just means per 100, so 8% is 8 per 100, or over 100. Now we need to simplify this, so I know I can divide top and bottom by 2. And so 8 divided by 2 is 4, 100 divided by 2 is 50. Looking again, I can then halve that again, so I can divide those both by 2 again. And so that gives me 2 over 25. Now 2 over 25, I can't simplify that anymore. Now I could have gone straight from the first number to here by dividing top and bottom by 4, and that would have absolutely worked as well. Either way, you get 2 over 25 as your answer. So we're asked in this question to do a comparative bar chart for the information in the table. Now a comparative bar chart is just a normal bar chart, but with this question we have 2 variables. We've got males and we've got females. So we're going to show that information just all on one bar chart. First thing to do is do a key. So how are we going to tell the difference between males and females? Well, I'm going to leave males blank and I'm going to shade in females. And the key is really important to show. Don't do any elaborate sort of spots or dots or anything, just have one unshaded and one shaded. Let's keep it simple. Okay, let's have a look at what the scale is going to be. So is it going up in 1? So 1, 2, 3, 4, 5. No, it's not. Let's check 2s. 2, 4, 6, 8, 10, 12, 14, 16 and 18 and 20. Brilliant. Okay, so we're going to put the males on first. And so, where is it? It goes up to 12. So let's put a bar up to 12. And that's going to be our males. And females goes up to 14. So I can extend that line a little bit for the females. And that's for 1991. So I'm going to shade in the females. Perfect. So that's those 2 done. Okay, 1992, the males goes up to 14. And the females goes up to 6. So let's draw that. And let's shade in the females. And the last one, so let's cross that out so we know we've done it. And the last one, the males goes up to 8 in 1993, which is about there. And the females goes up to 16. And it's shading the females. Now there's no need to write on the bars males and females, there's no need to write anywhere else. With the key we've got at the bottom, that's full marks. Okay, so we're asked to write these in ascending order. Now ascending means going up, so we're going to start with the smallest and end with the largest. So a plane ascends as it leaves the airport, and as it comes into the airport it descends. Anyway, so I'm going to first of all look at the denominators of each of these. Now it looks like we can make these all over 12. So I'm going to get them to the same denominator so I can easily compare them. So I'm looking at getting all of these over 12 because I know that 6, 2 and 4 all go into 12. So how do I get from 6 to 12? I times by 2. So I'm going to do the same to the top, times that by 2 and I get 10. On this next one, what do I do to 2 to get to 12? Times it by 6, so I'm going to do the same to the top, times that by 6, 1 times 6. And the last one, what do I do to 4 to get to 12? Well, I times it by 3, and then I'm going to times this one by 3. 3 times 3 is 9. Okay, so looking at the fractions I've got at the end here, so this one, and this one, you can see that b is the smallest. So I'm going to copy down the original fraction, not the 6/12 one. And looking at them, c looks the next smallest. And don't forget, we're going to copy down 3/4 and not 9/12. And then a looks like the largest because the numerator is the biggest. And again, be careful to copy down the original fraction. Just make sure that you don't copy down anything in yellow. The yellow fractions are there just to compare them. Make sure your answer contains only the fractions given to you in the question. Okay, so this question asks us to find all possible integer values. Now it's really important we understand that integer just means whole number, or whole numbers, I should say. Integer is just a whole number, so we're looking for all the whole numbers that are between -2 and 4, and that's all this is saying, that x is anywhere between -2 and 4. But because this doesn't have a line underneath it, it does not include that number, so it doesn't include -2. This one, however, does have a line underneath it, so it does include 4. So the first one's going to be -1, 0, 1, 2, 3, and we include the 4, but we don't include the -2. So this is our answer. Okay, so in this question we're asked to find the midpoint of line AB. So we can first of all just work out how many squares to jump from A to B. We're going to go across first, so we go across 1, 2, 3 squares. So we jump 3 squares. And then to go down we go 1, 2, 3, 4, 5. So we go down 5 squares. Okay, so a midpoint's a halfway point, so instead of jumping 3 squares to the right, we're going to jump 1.5 squares to the right. Instead of jumping 5 squares down, we're going to jump 1, 2.5 squares down. And that brings us to this point here. And this is our midpoint. Now it's kind of awkward because it's not on a crosshairs on the grid, and it's going to be a decimal coordinate. So let's have a think. We started off at a horizontal x-axis of x-coordinate of -3, and we jumped 1.5 to the right. So that's going to be at -1.5, or -1.5. And then when we went down from a height of 2 on the y-axis, and we went down 2.5 squares. So we're going to be at -0.5. And you can read this off by looking at the coordinate here, that it's halfway between -1 and -2, which is -1.5, and it's halfway between 0 and -1, which is -0.5. The best way to think of these questions is that the money here, £99, is split into an amount of piles, and J gets 5 of those piles and Anne gets 4 of those piles. The order the names come in the question is the order they are in the ratio. So this is J's stash and this is Anne's stash. So first step, we've got to work out how many piles there are in total. So we add 5 and 4 together, and there's going to be 9 piles of cash. Second step, well, we've got to work out how much is going to be in each of those piles. So we get the 99 and we divide it by the amount of piles. Okay, we want the same amount of money in each pile. So that's going to be 11. So there's going to be £11 in each of those piles. Now, J is going to get 5 of those piles, each pile having £11 in. So to work out how much J gets, we just do 5 times 11, which is 55. To work out how much Anne gets, we're going to do 4 times 11, because she's going to get 4 piles of this £11. So that's going to be 44. We can just check our answer by adding together the two amounts, because we're sharing the whole of the £99 between the two of them. 55 plus 44 is 99. Okay, so to do front elevations, we pretend that we are standing at the front, and this is my really bad picture of a person, and we need to draw down to scale exactly what we see. So we are not going to see. We're not going to see any of this. No, not going to see any of that. We're not going to see any of that either. So the only thing we're going to see is this bit here. And it's really important for front side elevations and plans that we don't have any 3D in the shape at all. So what's the width of that going to look like? Well, it's going to be 2 centimeters across. What's the height of it going to look like? Well, the height of that, shaded in blue, is going to be 6 centimeters. So when we draw this in, we need it to be a 2 across and 6 down. 1, 2, 3, 4, 5, 6 rectangle. Like that. So no 3D added in. You don't show the slope at all. That's exactly how we'll show the shape. Okay, so in this question we're asked to increase 240 by 21%, and we're going to do this without a calculator. So to find 21%, what we can do is find 10%, then we can double it to find 20%, and we can divide it by 10 to find 1%. So 10% would be 240 divided by 10, which is 24, and if I double that, I get 48. And then if I get the 10% and then divide that by 10, then I get 1%, which is 2.4. So to get to 21%, I need to add these two together. So I'm going to add these two together. And so what have I got? 4, then 8 plus 2 is 10, and then 4 plus the 1 is 5. So it's an increase of 50.4. Now it wants us to increase it by that amount, which means it doesn't want to find 21% of it, it wants to find the total amount. So we then need to add it on. So we've got 4, 0 plus 0, 4 plus 5, and then the 2. So my answer is 290.4. Okay, so the first thing we need to do is remember what the formula is for an area of a circle. Area is pi times r squared. Now we're given a diameter here because it goes all the way across the circle, so we need to find out what the radius is first. To do that we just halve the diameter, so 30 divided by 2 is 15. So the area is pi times 15 squared. Now chances are this is on the non-calculator paper, so I'm going to have to do this without a calculator. So pi times 15 squared, which is 225. Now in algebra, if you had x times 225, you would write it as 225x. Now with pi, it's not algebra, but it works the same way. So the answer in terms of pi, if I write the right number, is going to be 225 pi. And that's it. Because it's on the non-calculator, the only thing I can do, I've written it wrong again, the only thing I can do is estimate pi, and that's not what it asks for. It says leave your answer in terms of pi. So it's 225 pi is an acceptable answer. Okay, so we've done an experiment a number of times, and we found that the colours of the car, 35 red, 25 white, and 31 other. And we're asked to find the experimental probability of the next car being white. So the first thing you need to know is how many times you did it in total. So we add all of these together to see how many trials we had, and that's going to be 91. And experimental probability is dead easy. How many times did it come up? Well, the white came up 25 times. And how many trials did you have? Well, we had 91. So you put 25 over 91, and that's it. Okay, so we need 4 eggs to make 6 cupcakes. So 4 eggs leads to 6 cupcakes. And we're asked to find how many we need for 18 cupcakes. So to get from 6 to 18, we times by 3. So we're just going to do the same to this side. So times by 3 is 12, so we'll need 12 eggs. What you could have done is found out how many eggs are needed for 1 cupcake, and then found out how many are needed for 18. So you could have divided 4 by 6 and then times it by 18, but without a calculator this is much easier. Okay, so the easiest way of doing this question is to convert the 0.43 into 43. And to do that, I'm just going to times it by 100 to make it 43. Then when I've done that, I can just use whatever method I want. I'm going to use the grid method to multiply them. If you use a different method, that's absolutely fine, as long as you get the right answer. So 43 is 40 and 3, 16 is 10 and 6, and we're timesing them. So 10 times 40 is 400, 10 times 3 is 30, 4 times 6 is 24, but it's a 40, so I add 0, and 3 times 6 is 18. And we're going to add those up, 400 plus 30 plus 240 plus 18. So that's going to give me an 8 there, that's going to give me an 8 there, and that's going to give me a 6. Okay, when we've done that, we've got to remember that we timesed it by 100 originally. That means to undo that, we're going to have to divide the answer by 100. So, we know that 43 times 16 is 688, therefore 0.43 times 16 will be 100 times smaller, so that's going to be 6.88. I always find it easier with these questions just to do a simple sum first, so I'm going to do 2 times 3 equals 6. And I'm going to think how I can rewrite this. Well, I can put the 6 here, divide it by the 2, and that gets me the 3. So it's just a matter of moving the answer to the start and picking one of these guys to divide it by, and then we get the other one. In this question we have exactly the same thing, so what I like to do first of all is just rearrange the fact that I'm given. So I'm going to put the 2376 first, then we're going to divide by the 99, and I know that that will get me 24 if I did that. Now we've got to think about what we're doing in the actual question that it's given us. Well, we've times the top by 1000 and we've times the bottom by 100. Now when we times the top by 1000 it will make the answer 1000 times bigger, but when you're dividing it's basically the same as a fraction. Whenever you times the bottom by 100, say, which we have in this question, it actually makes the answer 100 times smaller. So we're making it 1000 times bigger and then 100 times smaller. So what are we doing in total? So one way of doing this is just to split that 1000 up by times 10 times 10 times 10, and the 100 times 10 times 10. So this times 10 will cancel, this times 10 will cancel, and we're just left with a answer that is 10 times bigger. So we've got the answer of 24 with a 0 on the end of it. Now what might be easier is to think of that in terms of divided by 10. When it's at the bottom of a fraction, or you're dividing it by the number, it just becomes a divide by 10. So the answer is 240. So the first thing to notice is the names here are in the same order as the numbers in the ratio. Now we're asked for the fraction that Tia receives. Now Tia receives 7 parts out of a total of, and let's just do the calculation. So 9 plus 6, 15, 15 plus 7 is 22. So it's 7 out of a total of 22. Now remember, you need to add all of the bits of the ratio together to work out how much there is in total for your fraction. Okay, so we're asked for the single transformation that maps shape A onto B. So I'm starting A, going to B. And I first of all got to figure out which transformation I'm looking at. Well, it's not an enlargement because it hasn't grown or shrunk, it's the same size. It's not a rotation or reflection because it's kind of the same way around, it's exactly the same shape. All that's happened is it's moved, and that means it's going to be a translation. So I'm going to say translation. Okay, now we need to figure out what the translation is. Now, always pick the same point on both shapes. I always pick the top left one. Okay, just make sure it's the same, doesn't matter which one you pick. So I'm going to pick the top left one on both shapes. Now I'm going to start at A and I'm going to try to get to B by using jumps. So I'm going to start off going right first. So 1, 2, 3. I'm in line with B now. And then I'm going to go down. So 1, 2, 3, 4 down. So I've gone 3 right and 4 down. And the reason we do the jumps is if you do them in the exam, you always get the right answer. The most common mistake with this is people counting lines. And if you have a look here, there's technically 4 lines here and people write down 4. It's not, it's 3. 3 is going to be the answer for this. So we've gone 3 right and 4 down. And the way we show this is with a little vector. The top one, and I'll put these as notes over here, the top one shows how far right you've gone, the bottom one how far up you've gone. Well, we've said we've gone 3 right, so that's nice and easy, so 3. But here we've gone 4 down, and the bottom one always shows how far up we've gone. So we've gone -4 up, otherwise 4 down. So if the top one is left, then it will be a negative number. If the bottom one is down, then it will be a negative number. Okay, so first of all, we're asked to find that to prove that they are congruent. Now, congruent means exactly the same lengths, exactly the same angles, exactly the same shape, so exactly the same thing. But you can rotate with congruency. Okay, so the proofs are side, side, side. Well, we only have 2 of the sides. Now, theoretically, we could work out the other side by using Pythagoras' theorem, but we don't actually have to do that. So you could use side, side, side by using Pythagoras, working out the third side, and then working from there. The other one is AAS, or ASA, which is angles, angle, side, angle. Now, we're only given one angle, which is the 90 degrees, so we're not going to be using that one. The other one is side, angle, side. Well, we have a side, and an angle and another side, but the problem is the angle needs to be between the sides, and here the 90 degrees isn't between those 2 sides, so it's not going to be that one. The last one is RHS, right angle, hypotenuse, side. So let's have a look and see if we've got that one. Well, we've got the right angle, we've got the hypotenuse, and then we've got another side. All 3 of those, obviously the right angle is the same, but all 3 of those are the same. So the right angle is there, the hypotenuse is 12 meters, and then the other side is 7 meters. So the proof that we use for this is just RHS. Okay, so in this question we're asked to complete the frequency tree. Now, frequency tree is like a probability tree diagram. We're just looking at the numbers. So it says there's 31 people, well, hence the 31 here, asked if they like football and rugby. From 14 people who liked football, so it means that there were 14 people who liked football. It says 4 like rugby. So there's 4 that like rugby. That means that there's 10 that don't like rugby, because there's 14 people who like football. From the people who did not like football, okay, so let's try and work this out. Well, there's 31 altogether, and there's 14 that did like football, so that means there's 17 left. Because that 31 needs to be split up evenly between the yes and the no. Okay, it doesn't talk about having maybe as an option here. And it says 6 of those people like rugby. So 6 of those people like rugby. Therefore, there needs to be 11 people who don't like rugby. Now, you can check this by adding up all of the ones over here. So if you add these all up, they have to add up to make 31. because every single one of those 31 people need to end somewhere on the right hand side, and they can't end in two places. Okay, so when it says make y the subject of the formula, it just means it needs y equals. So I always start off with writing the equation or formula down, and I'm going to put my lines in. Okay, so I need to get y on its own. So the first thing I'm going to do is get rid of that -1 by adding 1 to both sides. So we've got x plus 1 equals 9y. And then I'm going to divide by 9 both sides. So we get x plus 1 over 9, so all of it over 9, equals y. So the answer is x plus 1 over 9. To find prime factors, the easiest method is to do it as a little tree. I'm thinking of two numbers that multiply together to make 75. Now there's a few choices I can make, but I know that any number that ending in 0 or 5 is in the 5 times table. And let's have a think. 5 times 10 is 50, 5 times 5 is 25, so that's going to be 15 there. Then I'm going to split that 15 up. That 5 is a prime number, so we can stop there. So 15 is 3 times 5. Now both 3 and 5 are prime numbers, so we stop there. Now it says it wants it in index form, so we're going to start off with the 3, but there's no other 3's there. And write 3 times, and it's 5 times 5, which is going to be 5 squared. Now be careful to make sure that you've got the times there, and don't actually do 3 times 5 squared, because the answer just will give you 75. Okay, so in this question you might think that to get the answer to this, you do 40 divided by 5 to get to 8, so you divide that by 5 and you get one machine. The problem is that doesn't make any sense. If 5 machines take 40 minutes, that's almost an hour to make one toy, then what, one machine's going to do it in 8 minutes? It just doesn't make sense. And a question like this that doesn't make sense, if one increases, the other increases, is an inverse proportion question. Now there's an advanced way of doing it where you work out the formula and you do it that way. I'm going to show you a slightly different way that's maybe easier for some people. So if you think about the machines, which is one variable, and the time, which is the other, and we've got 5 machines and it takes 40 minutes, then if we times those together, we get something which I'm going to name machine time. Okay, I've just made that up. So 5 times 40 is 200. Now that 200 there is really special, because that 200 must always be the same. The machine time must always be the same. So it says we want to do it in 8 minutes. So I've got to think, right, what times 8 is 200, because machine time will always be the same. So I get my calculator and I'm going to do 200 divided by 8, and it's 25. So let's check that. 25 times 8 is 200, so it works. Now that is the answer, that we would take 25 machines. Let's just check if it makes sense. So 5 machines take ages, they take 40 minutes to make a toy, yet 25 machines take only 8 minutes to make a toy, so that makes sense. You'll notice that we've divided that by 5, but we've times this one by 5, and that's the way inverse proportion works. As you divide one of them, you times the other. The word estimate in the question means do not use a calculator, even if it comes up on the calculator exam. You can use the calculator to check that you've done the calculations correctly, but you should be able to answer the question in full without a calculator. So first thing I notice is we've got this root 27. Well, I don't know what root 27 is without a calculator, but root 27 is pretty much the same as root 25, and I know root 25 is 5. So I'm going to change that for a 5, because I'm rounding it, which is the part of estimate. Right, next one, 3.3. Well, whenever I round to one significant figure, so that's just going to be 3. And we've got a times 4.7, well, I'm going to round that one there to 5. So BidMaths tells me to do in the brackets first, so 5 take away 3, which is 2. And then 2 times 5 is 10. So the answer is 10. Okay, there are multiple ways of doing this. What I like to do is always make these top heavy, but what you could do is split this up, so you do 1 plus the 2 plus the third plus the 3/8, and then just, obviously 1 plus 2 is 3, and then just focus on what the answer to that is. I find it easier just to have one method for all the operations with mixed numbers, so we're going to make them top heavy. Now the way of doing that is you times the big number by the bottom, then add it to the top, times the big number by the bottom and add it to the top, and that gets rid of the big number. So 1 times 3 is 3, add to the top would be 4, and then keep the bottom the same. And the second fraction, 2 times the 8 is 16, add it to the top would be 19 over 8. Now, like we said in our previous videos, you need to make sure the bottom is the same number when you're adding. So to do that, I think it's going to be 24, so we're going to have to make them both 24. So I'm going to times the first fraction, top and bottom, by 3. By 8 even. So 3 times 8. And times the top and bottom for the second fraction by 3. So that gives us 32 over 24 plus, and then 19 times 3, I could do 20 times 3, which is 60, take away 3, which is 57, over 24. Now what I'm going to do here is add the tops together and keep the bottom the same. So 30 plus 50 is 80, 2 plus 7 is 9, so it's 89 over 24. Now what might be useful is I just do a quick 24 times table, so 1 times 24 is 24, then 48, and then add 4 would be 52, 62, 72, and then add another 24 will be well over 90, so I don't need to, 7, 8, 9, yeah it will be. So 3 times 24 is 72. Now the reason I'm doing that is because I need to make this a mixed number. So what I'm going to do is I'm going to find out how many 24s I can take away from 89, which is 3. And that would take away 72 from this number here. So how many have we got left over? Well, 89 take away 72 would be 17 over 24. So my answer would be 3 and 17 over 24. Okay, so we asked Hannah's invested some money in the bank, and she uses a formula to work out how much money she's given after a certain amount of years. So the 2,200 here is the amount of money that she had. The N here is the number of years, and the M is the amount in her account. So the only thing that really hasn't been discussed is this number here. This number here is a multiplier. So to find a multiplier, you start off with 100%, you add on the percentage increase, and then you divide by 100. So we're just going to do the other way. So we're going to start off with the multiplier. We're going to times it by 100 to get the percentage. So it's 101.1%. And then what we're going to do is just take away 100%, because that's the initial amount, and see what we've done to it. Well, we've increased it by 1.1%. So that shows a 1.1% increase. Okay, so we're asked to solve this simultaneous equation, but at the moment we don't have any of the coefficients the same. We've got x being 5 before it and then 6 before it, and y has a 3 before it and a 6 before it. So we need to do something about that first. Now I could times the top equation by 6 and the bottom one by 5, and that would get the x's the same. But if you have a look at the y's here, we've got 3y and 6y. So if I times everything at the top by 2, that will get them the same. So we've got to make sure we times everything by 2. So 5x becomes 10x, 3y becomes 6y, and 35 becomes 70. Now it might be easier to copy out the second equation again. Especially if you know you're going to subtract. So with simultaneous equations we always work downwards. So I'm just going to circle these to remind me we're going downwards. And the rule is if the matching coefficients, which is the y here, have the same sign, we subtract. If they have different sign, we add. And it's that simple. Well, they've got the same sign here, so we're going to subtract all three of these going downwards. So 10x take away 6x is 4x. 6y take away 6y is nothing, and the whole point is to get rid of those. And 70 take away 54 is 16. So we're going to put our lines in. And we're going to divide both sides by 4. So x equals 4. Now that's only half of the question done because we need to find out what y is. So I'm just going to substitute that value of x into the first equation, and you can choose either. So 5 times 4 plus 3y equals 35. So I put my lines in. So it's 20 plus 3y equals 35. Take away 20 from both sides. So 3y equals 15. And then divide by 3 both sides. So y equals 3. No, it doesn't. Y equals 5. And you can substitute that into the second equation here to check that it works. What is it? 24 plus 30, that would equal 54, so we know it's correct. Okay, so to convert an ordinary number into standard form, what you're going to do first of all is just write out the number. And you're going to figure out where the decimal point has to be to give us a number between 1 and 10, but not including 10. So let's try a few out. If I put the decimal point here, it's going to be 0.00341. Well, that's clearly less than 1. If I put it here, then that's going to give us 34.1. So we're a little closer, but we're not quite there. So let's remove those two because they didn't quite work out. The actual point is going to be here to make 3.41. Now that is a number between 1 and 10, so that's a big tick for us. Excellent. Okay, so we've got to find out how many times we jump between where the decimal point is now to where we want it. So 1, 2, 3, 4. So we jump 4 times. Now, to construct standard form, you put the number between 1 and 10 first. Then you just write times 10 to the power of. And in here goes the amount of jumps you needed. Okay, so to write our answer, we know that the number between 1 and 10 is 3.41, and it's always times 10. It's never divides, it's always times 10. And we've got to figure out whether it's going to be a positive 4 or a negative 4. Now there's a couple of ways of doing this. If you had to move the decimal point to the right, it's going to be a negative, and to the left it's a positive. Or an easier way of remembering it is if you've got a really small number, like a decimal, 0.0 something, then it's always going to be negative. So the answer here is going to be negative 4. Okay, so this is a non-calculated trigonometry question. So the way I'll start this is exactly the same as I start any trig question. I'm going to label the sides first. So that's my hypotenuse. This is my opposite down here. And this is my adjacent next to the marked angle and the right angle. And I'm going to cross out the one I don't use, which is the adjacent, because the other twos have values on them. Then I'm going to write out my SOHCAHTOA. So exactly the same process as before. These are 3 triangles, and you have to remember these. Now we're not going to use this one and this one because they both have an A in, and we've crossed that out. So we're looking at SOL. So this little triangle says that sine the angle equals the opposite, which is √3, over the hypotenuse, which is 2. So basically I need to know what value of sine gives me √3 over 2. Now there's a method I've shared in a previous video, which I'm just going to briefly go through. And what you do is you write down the values 0, 30, 45, 60 and 90. And with sine, if you circle one of them and you put the numbers on the left of the one you've circled over 2, then that's the sine value. So nice and easy. So let's have a look. The root here is √3, so I'll need 3 numbers to the left of the one I circle. So if I circle this one, I'll have 3 numbers to the left of it, which will be √3, and it's always over 2. So my answer is going to be x equals 60. And whilst you're revising, you can always just find out. You can type in sine 60, and when you type that in, you'll find the answer of √3 over 2 before you convert it to a decimal. Okay, so we're given a graph in this question, and it says use the graph to work out if A and B are in direct proportion. Now there's a few rules for direct proportion. The main rule is it needs to go through the origin, so it needs to start the bottom left. And the second rule is it needs to be a straight line. So the one I've just drawn now is in direct proportion, but here you can see that it doesn't start at the origin, and if it did start at the origin, it wouldn't be able to go down. It is a straight line though, but because it doesn't start at the origin, it doesn't go through 0, 0. You can say A and B are not in direct proportion. Okay, so to do this question, I'm going to start off with a number line, and I'm going to put the number given to us in the question in the middle, so 89.6. Now it says it's to the nearest tenth of a second, so what I want to do on the left hand side is put the next number down. So what could it have rounded to if it was slightly less? Well, the next one down would have been 89.5, and the next one up on the other side would have been 89.7. Now to find the bounds, we just find the halfway points, and this left hand one will be the lower bound, the right hand one will be the upper bound. So that's going to be 89.55 and 89.65. Now it says it wants it as an error interval and use t for the time. So we put t in the middle, then we put the greater than sign on the left hand side, and then just the normal inequality on the right hand side. Now these two signs here will always be the same. Okay, so when you're asked to do an error interval, it's that way around. So we're going to do our 89.55 on the left hand side and 89.65 on the right hand side. Now the reason why the inequality has an equals underneath it on the left hand side is it can be 89.55 and still round to 89.6. The reason it doesn't have one on the right hand side is 89.65 would have rounded to 89.7. So if you just remember, the things in the blue circles are always that way, and the letter it asks you for, just put in the middle. If it doesn't ask you for a letter, you can just pick any letter you want. You can call it X or something. And then the lower bound is on the left hand side and the upper bound is on the right hand side, and the lower bound's always here and the upper bound's always here. So we're given us a few sets in this question, and we're asked to complete the Venn diagram. And it says that A is multiples of 4. It says that A and B is 16 and 36, and it says A or B is all of those values. So first thing that the easiest thing to do first of all is use this information. A and B are the values that are in both of the circles A and B.
So we can fill that in quite nicely, quite easily, and we can actually cross those off as we go. Okay, next ones to figure out are the ones that are just in A. With 16 and 36 are in both, then all we need to do is just find the numbers in the 4 times table in our list at the top. And the list at the top, I think of it E for everything. Those are all the values in the total Venn diagram. So we've got 12 and I think we've got an 80 there. So 80, we go down there. Okay, now looking down our list at the bottom, we've got a list of values that are in A or B. That just means could be in A, could be in B, could be in both. Well, we've already should cross out some of these because we've already used them. So 16 and 36, and it leaves us with 1 and 17. Well, they've got to go somewhere, so they can go over here. So 1 and 17 have been used up. And the problem is that it says that we also have an 11 and 27, and they've not been assigned to anywhere inside the Venn diagram, so they're going to go outside. And I always just check by adding up how many numbers I've put down. So 1, 2, 3, 4, 5, 6, 7, 8, and I should have put down, and I'm counting the numbers at the top, 1, 2, 3, 4, 5, 6, 7, 8. So chances are I've got it right. Now there's a couple of different ways of doing this question. Either you could rearrange this into y equals mx plus c and then draw the line that way, or there's a slightly different method which is a little bit quicker. So we're going to do the slightly quicker method so that you understand it and you're happy with it. So we're going to find out the y-intercept first, and the way we're going to do that is at the y-intercept we know that x equals 0. Now if x equals 0, we can rewrite that equation, but x equals 0, so that gets rid of the x term. So we're going to end up with minus 3y equals minus 30, because the x's we've got rid of them. Okay, then I'll put my lines in, and so I'm going to divide both sides by minus 3, so that will just be y equals, and then a minus divided by a minus is a positive, 30 divided by 3 is 10. So y is 10. And let's just clean this up a little bit, give ourselves more room. Then I'm going to find the x-intercept, which is not something you use very often, but at the x-axis, y equals 0. So we're going to go do the same thing, but instead of getting rid of the x now, we're going to get rid of the y. So rewriting the equation that we're given in the question, I'm going to write 10x, I'm not going to write minus 3y because it's equaling 0, equals minus 30. And I'm going to put my lines in, and I'm going to divide both sides by 10, so x equals minus 3. So our y-intercept is 10 and our x-intercept is minus 3. So I'm going to plot the y-intercept as 10 and the x-intercept as minus 3, which would be over here. Then I'm going to draw my line to connect them, and you just need to do this with one clean line through, and I'm going to do it in 2, but you really shouldn't do that. You should just put your ruler down and just draw a line straight through them. And don't forget that you start the line where the graph starts and you end it where the graph ends. Otherwise, if you have gaps in it, you might lose marks. So for this, let's finish it off. So our y-intercept was 10 and our x-intercept was minus 3.
I hope you enjoyed that video, and if you liked it, please click like, and if you want to see more from us, please click subscribe. Don't forget you can go to our website where there's this paper, but there's also a whole load of other practice, and we've got topic busters for every single topic that you can go through, all obviously completely free, and you can sign up and it saves your scores. There's also a new function, a new thing we've got called the Revisionator, which is really good for the basic skills as well. So you can rattle through a random set of skills to test that you're ready. I hope all the best of luck for you on your exam, and if you do well, or if you don't do so well, please let us know either way. Thank you very much.